Welcome to the Frog Engineering Airsoft YouTube channel. My name is Pavel. If you want to learn about Frog Engineering HPA GBBR engine, then check my rec. The idea behind Frog Engineering HPA system is to allow you run your GBBRs in all conditions and do it kind of cheaply. You know, there are systems like the Daytona gun, which are very expensive and use very customized parts. It's a closed bolt system. With Frog Engineering HPA engine, you can print most of the required parts and the magazines yourself at home if you own a 3D printer. And most of the parts in the gun are actually stock parts. You don't need to pay a lot of money for expensive magazines with the gas valves that fail, like the regular GBBRs. And most of the internal components are the exact same components you get in the original gun, meaning all replacement parts will work with the converted gun. You can do whatever you want. Replace the bolt, buy a new bolt catch, change the trigger mechanism, everything is completely standard, apart from tiny part, which is the conversion. So let's have a look on some of the guns I have on my rack right now. All of them, actually not all of them, 7 out of 8 are GBBRs already tapped with HPA conversions. The last one here is an AEG. Check this out. There was a time in my career when I would kill for having this feature on my replica. What the fuck? We have here different systems like VFC HK416 family, HK417 family, and WE M4 family. So first let's have a look on this gun because it's leaving my workshop soon. It's already finished. This is an M27 GBBR from VFC Umarex. It's a GBB, of course. It's already tapped with HPA, so let's have a look into it. I won't be talking about the gun itself and from like VFC or Umarex, the M27 GBBR, because there are lots of reviews on the web already. The goal is to talk about the HPA system. First things first, everybody who owns a GBBR knows its limitations, especially temperature and FPS drop or energy drop when you shoot and you empty out the magazine. The issue is that the magazines or GBBRs freeze. Even in warm days, you lose a lot of energy as you shoot and the magazine is getting colder. And for people who live in rather cold climates, it might be even not possible to use a GBBR. So what to do about this? You can convert your gun, like this one, to HPA. Let's see what's inside. First, the magazine. The magazine used by Frog Engineering HPA conversion is actually 3D printed. You can actually print it yourself if you want to. I have a problem with focusing. This is my first video, so probably it will be shit. And the only modification done to this gun is the conversion, which is mounted inside. So let's have a look. The upper remains almost intact. There is some slight filing done inside so that the conversion can fit, but the change is actually the lower. You can see that here in the magazine well, maybe here, there is mounted the conversion kit and the hose is routed down and to the pistol grip, so you can connect your HPA line here. The magazine goes inside and it has a functional bolt catch, so right now the magazine is empty and probably you can't see it too well, but yeah, it works. Let's put it back together and let's give it some use. Now that we have complete gun, we can check the bolt catch. You see that it locked back, the magazine is empty and inserted, and when I remove it, the bolt will go back. Nice. One thing you need to be aware of when you power up this system is that you need to connect the pressure when the gun is on safe. In VFC, when the trigger is pulled and the valve knocker goes forward, you cannot put the gun back on safety. Right now I can do it. I know that gun is empty, so don't be afraid, it won't shoot. And now I cannot. So if I put the pressure here, then the valve inside is knocked and the gun will automatically shoot. So we never do it. First we need to charge it, then we need to set it to safe. And now we can connect our HPA. The magazine is empty. The chamber is also empty, but you probably can't see. I'm not holding the bolt catch, magazine is empty, so the bolt will immediately lock back. And now I'll hold the bolt catch down so that it does not lock and we can shoot some more. Let's do the same with full auto. HPA works. This gun is set to shoot 1.9 joules at 0.36 gram BBs on an R-hop, and it has a barrel 6.02 millimeters diameter, I believe. These all give its range of about 75 to 80 meters, depends on the conditions. One thing to notice is that it has a custom printed buffer, and this buffer boosts the rate of fire. So one thing that is important, the lighter moving components are, I mean the bolt and the buffer, the quicker the gun will shoot. So this one is already has already exchanged buffer to a lighter one, which was 3D printed. You can find the link in the description if you want to print one for yourself. If we are talking about the rate of fire, is that the rate of fire and the pressure on which the gun has to run depends highly on the type of regulator you use. So the best one is extremely high flow regulator. In my case, I have two regulators available. One is the Minecraft HRR and the second one is the Redline SFR, I believe. And on Minecraft regulator, this gun has 12 BBs per second, while on the Redline it has 17 BBs per second. What is important in the VFC converted guns is that they are very airflow consuming, and by that I mean that you need to have a very high flow regulator, and most likely you will have to limit the rate of fire down by putting heavier components into it, because if the components will be too light, the mechanism of the gun will work, but the pressure going into the gun will be too low to keep the constant energy output on each BB which you shoot. So for example, this one has 17 BBs per second, but if I would be using some regulator with lower flow than the Redline, then I would most likely have to reinsert some heavier buffer inside to slow the gun down, to allow it to refresh the pressure before the next shot on full auto happens. The more FPS the gun has, the more flow it needs to shoot with the same energy and the same rate of fire. Meaning a CQB gun with 1.1 joules of energy will require less flow and can have a smaller flow regulator than this assault rifle with 1.9 joules of energy. Let's put it on chrono and see how it shoots. I won't go and shoot it outside because today is extremely windy day, and this demonstration will not show anything. But with some of the other guns I already converted, when the weather improves, I believe I will record something to show you how they really perform. Okay, so I hope you liked the video. This is the first one. There will be more coming with different systems that I convert and different replicas into which I mount those conversions. If you want to find out more about this, click the subscribe button, give me a like, and let's meet you in another video. Additionally, I have a Facebook page which has just been started, so you can visit it to get some more information.